Okay, I need to get that fixed. That's not all showing up. But Chapter 1 is Essentials of Geometry. So it's just a lot of background information on how to do the course. A lot of terminology, a lot of notation, that type of thing. Today we're going to cover sections 1.1 and 1.2. 1.1 is identifying points, lines, and planes. 1.2, we're going to use segments and congruence. There's your learning objectives. And so the first page in the notes. There are three undefined terms in geometry. Way back in ancient Greece, when they first started the subject of geometry, there was a guy named Euclid. And he's the one that came up with these ideas that we use. We are studying Euclidean geometry. And he had to base his geometry on something. So he came up with the idea of, anybody know what the three undefined terms of geometry would be? Okay, point, line, and plane. He invented those ideas. Okay, so the point is the basic unit of geometry. It has no size, is infinitely small, and only has location. So I take this place in space, take my finger away, there's a point, okay? It doesn't have size, but it's a location in space. That's what a point is. You name a point with a capital letter. Okay, so for example, if I had this point here, I can call it A, capital letter A. That would be point A. Name a point with a capital letter. The second term is line. A line is a straight arrangement of points. Because a point doesn't have any size, a line has an infinite number of points. Infinitely many points on a line. A line has infinite length because a line, we typically think of a line as a line segment. You know, like this line here. We think of that as a line, but that's a line segment in our terminology because a line, as we're talking about, would keep going on forever in both directions. Okay, so a line extends forever in both directions. You name a line by 2 points on the line or a cursive lowercase letter. What that looks like is if I have, so we've got, this is my line. I put arrows on both ends of the line because to show that it keeps going forever in both directions. And then I would have 2 points named on the line somewhere, A and B, for example. And so I would name this with A, B, and a symbol for a line above it. Oh, it didn't show up. Let me put it over here. So it would be AB with the symbol of a line above it. The symbol of a line is just what a line looks like. It's a little segment with arrows above it. And then A, B, the two letters that are on the line. Doesn't matter what order. You could call it BA or AB on a line. The order does not matter. All right, any questions? And then from time to time they may put like a cursive A here, then I would just call that, I could call that, if it had it like that, then you would call it line A, like that. That doesn't happen that often, though. Then our third term of geometry is plane. Anybody know what a plane is? Can somebody give me an example of a plane in this room? Okay, a plane could be your desktop, the ceiling, the chalkboard is a plane, right? It's any flat surface that, those are not true planes because a plane also extends forever in all directions. Okay, but these are part of planes. Okay, so a plane has length and width, but no thickness. Length and width, but no thickness. It's a flat surface that extends forever. And a plane is named by 3 points or a capital cursive letter. 3 points or a capital cursive letter. So I'll draw what a plane would look like. There's on a piece of paper, that's typically how a plane is drawn, and then there may be somewhere in that plane they would have 3 points. We'll say they're A, B, and C. Those are my 3 points. So if I named this plane, I would call it ABC. The other way that they name the plane is they may, let's see, where's my eraser? I think that's the eraser. Yeah. They may have like A, capital A, like that. So I could, if they do that, then I call it plane A. That's the other way to name a plane.
Students, all freshmen last names N through Z, please go down to the Hall of Excellence at this time for iPad pickup. Please bring your student ID. If you signed up to bring your own device, you do not need to come down at this time. If you still have your Global Campus iPad, please keep it and don't come down at this time. Thank you.
All right, everybody got the terminology? Okay. Moving on, some more definitions. Collinear. What do you think collinear means?
It's linear to something else.
No, that's not it. Oh well, if you're talking about a point, it is. I take that back. That would be if you were talking about a point. It's not meaning 2 lines. It's talking about points, right? The points are collinear, means they are on the same line. They are on the same line. So these points, these 3 points, are collinear. They're on the same line. Non-collinear would mean this point that's off the line here is non-collinear with the other points on the line. All right? So it means on the same line. Collinear. What do you think coplanar means? Yep.
On the same plane.
Yeah, it would be on the same plane. It's 3 points on the same plane. So a tabletop with 3 points on the tabletop, or in this case 4 points on the tabletop, that would be a coplanar. Those points would be coplanar. Non-coplanar, one of the points is not on the plane. All right? Those 4 points are non-coplanar because 1 point is not on the plane. 3 of the points are coplanar, but if you're talking about 4 points, you would say they're non-coplanar. All right, any questions? Give 2 other names for line PQ and for plane R. So how could we name this line PQ? How else could I name the line PQ that's shown there? Based on how we talked about how you can name lines. 2 other names for PQ. All right. One thing I can do, very simply reverse the letters. So we could say QP. I just switched the order of the letters. That's one way. What else identifies that line? Yeah. Yes. We have the lowercase n here, right? So I could call it line n. Okay, what about the plane R? Right? The plane R. R doesn't have any points by it, so we just can use the single letter there. It's a capital. That's supposed to be a cursive letter. Okay, it's bolded, so that's why you know it's cursive. But so we could call it plane R. What else could I name it? What else could I name it? Look back and see how you name planes, and how else could I name that plane? Yes, go ahead.
You can also name it by 3 points, so it would be like a plane SPT.
Yep, we could say plane SP V, right? We don't want we can't call it SPT because those are all in the same line, and that wouldn't make a plane. So you'd have to use SP and V, or we could name it STV, right? SPV or STV. All right, any questions? Okay, name 3 points that are collinear in this picture. 3 points that are collinear. Collinear means on the same line. What 3 points are collinear? Go ahead, yes. SPT. So for collinear, we could say SPT. What about coplanar? Coplanar means on the same plane. Name 4 points that are coplanar. You can't use R, it doesn't have a point by it. But you can use anything with a point by it on that plane. Go ahead, yes. VS, what'd you say, P?
VSPT.
Yeah, VSPT would work. So we could say coplanar, we could say VSPT. Right. They're all on that plane. We couldn't say VQ PT because Q is not in that plane. All right, any questions? Moving on. Defined terms of geometry can be described using known words such as point and line. So now these other terms, we're going to use point and line to define them. The first one is a line segment. I already talked about line segment. It consists of 2 points called the end points of the segment and all the points between them that are collinear with the 2 points. So all the points in between the 2 points are on the same line. So if I were to draw a picture, let's see how they did it here. So if I had no, let's go back. If I were to draw a picture of a line segment, I would have an endpoint here and an endpoint there. There's my line segment, right? And if these were points A and B, I would name it AB with a segment over it. No arrows on the segment above it. It's just a segment. If it were a line, I put arrows on the end of this symbol. But it's just a segment, so I just draw a line. That's line AB. Array is the next term. A ray consists of an endpoint A and all the points that lie on the same side of A as B. All the points on the same side of A as B. Now, for a ray, let's draw the ray. That they're talking. Come on. If we draw the ray they're talking about. So there's A, and then here's the point B. The order of the letters, make a little note, okay, and say order of the letters matters when you name it. Which point do you think comes first when I name a ray? Anybody? What point do you think I have to give first? Yes.
A.
Yes, I have to name the end point first. Okay? So the end point in this ray, it extends forever towards B. A is the end point. So when I name this ray, I might have a B here, I might have a C, D. Those other letters don't matter which one I use, but I have to start it with A, and then I would call this ray AB. If it had another point on it, say C, I could also call it ray AC. Same thing as ray AB, because it keeps going in that direction. So any other point on that ray can come second, but I have to start it with the end point. So I would name this AB with a line segment, an arrow over it, pointing to the right. AB. Questions? Everybody have it? All right. So, opposite rays. Opposite rays share the same endpoint and go in opposite directions along the same line. An example, let's go back. An example of opposite rays. So here's, they start at A, right? And they go both directions Come on. They go both directions. The rays go in opposite directions, right? And naming this, you know, I might have a B over here, and I might have a C over there. So I could name it. I name it as a line segment, not as a ray, because the two rays going in opposite directions make a line. So I would name this line AB or line AC. Either one would work. Or I could name it line BC. Any of those would work. Okay, everybody have it? Okay. What's another name for segment GH? How else could I name segment GH? Go ahead. Yes, just reverse the letters. So HG would be another name for segment GH. You reverse the letters. I couldn't call it segment JG or JH. That's a different length. HG is this length. JG and JH are different lengths. A segment has a set length. Okay, so I can only reverse the points. Name all the rays with endpoint J. Which of these rays are opposite rays? So give me one ray with an endpoint, with the endpoint as J. Okay, go ahead.
JF.
Okay, JF. So I'd write it J, F, and J is the starting point, so the arrow, we put the arrow over it, F comes second. Give me another one. Right here, why don't you give me one? Give me another ray.
JE.
Okay, so we have JE would be another one. Okay. Go ahead, next person in the row. Give me a
JH.
JH. Okay. Give me another one. Go ahead. You. JG. All right, you guys got it. Pick that up, okay? Now, which ones would be the opposite rays? Give me a pair of opposite rays. Yes.
JE and JF.
Yes, JE and JF are opposite rays. Give me another pair. There's another pair of opposite rays. Why don't you give me one? Opposite rays, besides JE and JF.
Me?
Yeah, go ahead.
JG and JH.
Yeah, JG and JH. Okay. All right, any questions? Everybody has it. All right. Name a plane and a line that is in, sketch a plane and a line that is in the plane.
Students, all sophomores, last name A through M, need to report to the Hall of Excellence to pick up their iPads at this time. Please bring your student ID. If you signed up to bring your own device, you don't need to come down at this time. If you still have your Global Campus iPad, please keep it with you and don't come down at this time. Thank you.
All right. So, you guys are going down? Okay. Sketch a plane and a line that is in the plane. Okay, so if I sketch a plane, I'm going to draw a four-sided shape. And then a line in the plane would be something that looks like that. That is a plane and a line in the plane. All the points in the line are in the plane. There's their example. Sketch a plane and a line that does not intersect the plane. So that's going to look like there's a picture. Plane, this is plane M in line L. Line L does not intersect M. No point in L. Even if I extend them both forever in one direction, they're not going to intersect. Plane and a line that does intersect the plane. And a plane and a line that intersects the plane in one point. There's an example of that. See how they made, when they drew this line to show that it goes through the plane in one point, they made where it intersects the plane, after that they made a dotted line. That means this line is behind the plane. You wouldn't be able to see it. All right. The only place that this line intersects the plane is right there. That point. Okay, any questions? No questions. Okay. Two planes that intersect in a line. All right? Two planes that intersect in a line. Looks like. This is telling you how to do it. Draw a vertical plane. Shade the plane. Draw, the second one can be horizontal. And you would show dashed lines where they show where they intersect. These are two planes that intersect. The green one is vertical, the blue one is horizontal. What do they intersect in? What does the intersection form? It forms a line. Line JM. Now, they don't have to be vertical and horizontal. You know, I could have a plane going this way and another plane going that way. You know, just as long as they intersect in a line. It's two planes that intersect. Everybody have it? All right, section 1.2. Section 1.2. I'm going to have to move quicker to get through all this. So, section 1.2. Use segments and congruence. AB is used to name a line segment. Okay? Oh. So I name a line segment with two letters and a line over it. If I want to talk about the distance of that line segment, then you just put AB or MAB. We won't use, we hardly ever use M, that means measure, of AB. We'll just use this. Just write AB. Don't put a symbol over it. If it's just the two letters, it's talking about length. All right, so I would say, just know the difference. If you put a line over it, you're talking about the picture itself, the actual thing. If you just have the letters, no symbol, talking about length. Apostolate is a rule accepted without proof. Euclid, when he came up with the idea of geometry, he had nothing to base it on. So he made up postulates, and these were not proven. He just said this is a rule that we're going to use in all of geometry, and they went with it. Okay, there was no proof to it. Segment addition postulate. If B is between A and C, then AB plus BC equals AC. Let's look at a picture of it. So we're talking about, for segment addition, if I had A here, B there, and C there, right? What this is saying is AB plus BC is the same thing as AC. Segment addition. All right, you can add the two segments to make the longer segment. Or you can reverse it. If AB plus BC equals AC, then B is between A and C. Then B is between A and C. That's segment addition. Everybody have it? All right, moving on. Measure the lengths of ST to the nearest tenth of a centimeter. You don't have your ruler yet, so you can't do it. We'll practice measuring later. But if I were to measure that length to the tenth of a centimeter, you would measure it in millimeters. That's the smallest marks on your ruler. Here it shows you what we're talking about. The corner. So if we lined S up with 2 and T up with 5.4, right? How many? So that would be 1, 2, 3.4. It would be 3.4 centimeters, right? If they started on the 2. Personally, I would start on the 0 and just see where it ends up. It would end up right here at 3.4. That's ruler postulate. All right, so you're subtracting the larger number. You subtract, or you subtract one from the other. 5.4 minus 2 is 3.4. If you did it, but they put absolute values around it, so that if you did it the other way, if you did 2 minus 5.4, you'd get negative 3.4, but absolute value means positive. So it'd still be 3.4. That's the ruler postulate. All right, apply the segment addition postulate. Cities shown on the map lie approximately in a straight line. Use the given distances to find the distance from Lubbock, Texas, to St. Louis, Missouri. What would I add together to find that distance? Yes?
380 plus 360.
Right, 380 plus 360. It's that simple. So we would apply the segment addition postulate and take 380 plus 360, we get 740. That's segment addition. All right, any questions? Moving on. Use the diagram to find GH. A little bit different here. How do you think I could find GH? Yeah.
Don't you subtract the 36?
Yeah, we'd subtract, okay? Because we can set it up with segment addition postulate. You might set it up as FG, segment FG plus segment GH is equal to segment FH. That's segment addition. And then we would plug in, right? You'd plug in the numbers. So FG is 21 plus, we don't know what GH is. GH stays as that, but we do know FH. FH is 36. Right? And then, all right, so then we would do algebra to solve for GH. So we would subtract 21. We would get GH is equal to what? 15. That's what I'm talking about, showing your work. Right? At least show this. Show this and then the next step. That would be showing your work. All right, so that's how we would find the length. All right, they do the same thing here. And then use segments and congruence. Two segments are congruent segments if they have the same length. If segments have the same length, they're congruent. Okay, length, to show lengths are equal, I would write, remember there's no symbol over it if it's a number. A length is a number. There's no symbol over the number. So AB equals CD. That's saying this length is the same, the length of AB is the same as the length of CD. When we use congruence, we're talking about the picture, right? So then I take this picture has the same length as this picture. So they are congruent. The pictures are the same. So I say I use the symbol above it. Segment AB is congruent to segment CD. So when you use congruence, you put the symbol over it. When you use length, which is a number, you just put the letters. Okay, compare segments for congruence. All right, we'll just go through this really quick here. If we plot these points, we're going to determine if they're congruent. So I plot JK, I plot LM, and since they're horizontal and vertical, I can count the boxes. 1, 2, 3, 4, 5. JK is 5 long. What about LM? 1, 2, 3, 4, 5. It's 5 long. So they're both the same length, so they are going to be congruent. If they're the same length, they're congruent. They don't have to run the same direction or anything like that. If they are the same length, they're congruent. So they use the ruler postulate. They use the numbers. Okay, and we determined they had the same length, so we say they're congruent. See, is that our last example? Yes, that's it. Okay.